So thank you, Lance and Harish.
Perfect. Thank you, Margaret. I'll go ahead and kick it off. Just a few items to get started before we jump right in. So just to introduce myself, my name is Lance Wills. I'm the head of AI growth at Datatron. Super happy to be here and really wanted to give you a little background on how this webinar came to be. So Harish Doddi, Datatron's founder and CEO, has such a fascinating background. I always wanted to ask him about his time at those early companies, Twitter, Snap, and Lyft, and never really got around to it. And so, once I started working with the data mine on this event, just made sense to tackle that. And I think it'll be very valuable for students to hear about his experiences. And so that's really where the background of this came to be. As Margaret mentioned, please do ask your questions in the chat. We'll probably just do it, just type them in, and then we'll probably select a few at the end. And then after the webinar offline, we'll select one lucky winner to receive a pair of our fabulous Datatron Mo Models, Mo Problems socks. And so hopefully you guys can see those. They're really, really fun. And the way that this came to be, I'll talk a little bit about that tagline, Mo Models, Mo Problems, as well as give you a brief intro into Datatron, is as these model inventories grow at these enterprises, they become a little bit cumbersome to manage. So Datatron has a model catalog to help you manage hundreds to thousands of those models. We also help you monitor those models for bias, drift, and performance anomalies, among other KPIs. And then we help you receive alerts to catch issues before they become problems. So obviously you guys have seen some stories in the news about bias issues, et cetera. So we want to make sure we're on top of that and support responsible and ethical AI. And then we also support models built on any stack or any library, which reduces the coding necessary and accelerates that model deployment velocity from what can generally take 6 to 9 months to get a model from the lab into production down to weeks or even just a few days. And it also allows a single engineer to manage hundreds and thousands of models. So without further ado, I'd like to welcome Datatron's founder and CEO, Harish Doddi. Harish, welcome. Thank you for joining us today.
Thank you. Thank you so much. Great to see you all today.
Perfect. We want to jump right in. Harish, just want to introduce you to the audience here today. Just tell us a little bit about yourself, where you grew up, where you went to school, and what you studied.
Yeah, certainly. So I actually grew up in India, went to IIIT, one of the prestigious institutions there, came for my grad school to Stanford, which is where I have done specialization with master's in computer science with core focus on systems and distributed systems as well. So have been pretty much experienced and really interested in exploring systems area, distributed systems area, and as well as databases. These were some of my interests while studying, but then got into the industry after that.
Super. Thank you very much. And we'll fast forward. I know you worked at other companies, including Oracle, but let's jump right into your time at Twitter. Tell us a little bit about what you were working on and how big Twitter was when you joined.
Twitter was roughly 200 people. So it's early days. I joined at a time where I don't know if any one of you remember the famous fail whale, which is whenever a celebrity joins Twitter, it's the system almost goes down because of the traffic that we experience. But my core focus at Twitter was I was mainly working on open source software. We were contributing a ton of open source at the point in time. In fact, at that time we have one of the world's largest Cassandra cluster, which is an open source database. But I really worked on something called as Blobster, which is Twitter's photo storage. So we used to have millions of photos every day. And it is absolutely important to give a seamless experience to users, particularly they want to express their thoughts through photos, or they would like to have that good experience when it comes to photos, not just tweets. Because as you guys know, tweets, once you tweet something, it gets publicized to millions of users. Same thing should happen with photos. So it was like almost like a 2.5-year project, purely on infrastructure. It was able to help the company save like hundreds of millions of dollars in costs on the storage side because of our architecture that we designed, and also be able to cut the latency by 100 times as well.
Got it. And then was this falling under the umbrella of machine learning or not quite yet?
This is more on infrastructure. So a lot of backend systems, the lower end infrastructure part of it.
Got it. Okay. Then you went to Snap and you were working on scaling stories. So tell us about that, and how did data science play a role, and what kind of challenges you incurred?
Yeah, so I was an early employee in Snap, pretty much like built Snap stories from scratch. Scaling was a big issue from day one. We always have to think about a large number of stories getting uploaded. Today, obviously, as you guys know, they're doing billions of stories, but when we have to come up with a system, you need a scalable system from day one. A lot of experience went in. There was a work relating to data science, recognizing the patterns of the users, how are different users behaving with the stories, what are the likely predictions and whatnot. But yeah, it was like a mix of infrastructure and data science as well.
So really starting to move you in a little bit more into that data science world. So how big was Snap when you joined?
Under 10 people. So it's like very early days.
Okay, wow. And then what kinds of tools, libraries, what kind of stack were you working on?
So we were primarily working on Google App Engine, which is the backend, because it's based on Google Cloud. That was the primary infrastructure. But we were like using like Python, Java. These are the main two languages we were using in the backend. On the front end, these are like typical iOS apps and Android apps.
And then how much did you rely on, let's say, open source solutions versus off the shelf?
So obviously, when you're a startup, a tiny startup, you don't have budgets, you don't have any allocation of any costs or anything. So majority of it is relying on open source and like taking the open source from the market, and trying to see what can we do customization to that to make it enable. So I was actually, so Airbnb's project, one of my friends' project is Kronos. So I brought Kronos into Snap, which was also an open source project. I also brought like Redis, the real-time database, the usage of Redis into Snap as well. So we were relying a lot more on open source, but that's because of the stage of the company.
Got it. Makes a lot of sense. And I think we'll touch a little bit more on open source a little bit later on, because I think that's something that we run up against at Datatron as well. What were some of the major challenges that you had to work through? Obviously, being a small team, resource constrained, but what were the projects, kind of speed bumps or road bumps within those projects that you encountered?
So most importantly, as a small company, you have to do a lot of things end to end, and there is always like resource as a constraint in general, whether it is people, whether it is hardware, whether it is getting any sort of other software resources and whatnot. So it's always like at every single point there is actually a decision where there are multiple paths to take, and you need to choose the path that is most optimal at that point in time. May not be the best path. We were always more like, we want to move fast. That was more the culture. Break things, fix it quickly over the fly. It was. I mean, obviously, as the company grew, that became less of an issue because you have more and more people to work with. But in the beginning, decision making, whether it is architecture decisions, whether it is infrastructure decisions, every decision has a huge impact. Like the scaling I was talking about, we have to design an architecture that has to scale quite big in the future. And if we haven't thought about that in the early on, it wouldn't have scale.
Got it. Very interesting. Obviously getting pulled in a lot of different directions. Maybe there's a little bit of tidbit or some sort of workflow hacks or anything that you can share to help, some of the students. How did you prioritize that work? Was it just decisions made on revenue? Was it sort of, the CEO comes running to you and says, hey, Harish, I need you to work on this? Or how did you prioritize all the different, initiatives you were working on?
Most of it is through experience, because when you work in a high stressful pressure environment, it's very different from academia. As you can see, it's like very, very different, because industry is like more practical. You have to take there is always like the ideal path, but there is also like what could be an optimal at this point in time and what could be more realistic. So somewhere between the optimal and realistic is where the path, the middle ground between them would be the right path to take. Sometimes people come from academia, they would like to think of the best solution out there on day one. But most of the time that doesn't work like that. Always it starts something small and then like try to build on top of it. That would be the right path that I could advise.
Got it. Okay, that's great. And definitely, if you have an audience out there, if you have any questions about any of these things, Snap, et cetera, please do ask them in the chat. But next, we'll go ahead and talk about your time at Lyft. So what was your role and what were you working on, and how big was Lyft when you joined?
Lyft was pretty, very small when I joined. I was very excited because I thought the next thing would be all about ride sharing. These were like early days of sharing economy. And a lot of people are really skeptical, but I really believed in that model. I think when Lyft was my more in-depth experience into data science, because my project at Lyft was the first AI project, which is all about trying to come up with the best price for a ride, because you can always have a price for a particular ride based on distance and time metric, but you can also be intelligent and more smart on coming up with a dynamic price. So pricing is something that pretty much like I don't have data science experience, but I have to learn it on the fly. But my engineering experience combined with the data science experience have accelerated things quite a lot. So that was like an interesting project. And AI is being very, very skeptical, because a lot of times AI has been viewed as a pure R&D box, where people try out things in a toy environment, but until you prove that this particular model that you're building could be a pricing model, could be a fraud model, could be a recommendations model, what is the dollars in, what is the dollars out? And that was a question from day one that we have been really focused upon, because AI is viewed as completely skeptical. So bringing that AI, whatever we have practiced in theory, into reality, into a real production environment, was night and day for us.
So just to clarify, obviously you have a very technical background. You didn't necessarily have a deep training in AI or ML, but you sort of learned on-the-job training as part of this role. Obviously, we see your career arc move more and more towards that progressively. But is that fair to say? You essentially sort of picked it up and learned on the job?
Yeah, so I was more on the practical application of the AI. It was not about some sort of theory or some sort of research. That was not the case. It was really, really practical as I had the exposure, like showing the business that we are actually moving the needle rather than claiming that this might move the needle. There is a big difference between the both. So I was more involved, from a practical standpoint on the applications of the AI applications. And once we have also realized how to interact with the business leaders, because when you have AI, it's not that straightforward to communicate this correctly, and really showing that value and incrementally unlocking more and more investment, which actually led to exponential increase of AI use cases. Pricing was the first one, but there are now like hundreds of use cases.
So let's unpack that a little bit more specific around the search pricing model. Obviously, a small team, you're probably an individual contributor. And so talk to me a little bit about the success you were able to demonstrate to those executives through the surge pricing model, and then how that helped grow your career.
Yeah. So first of all, a lot of people view this whole data science as you model once and you forget, but that's not what happens in reality. In reality, whatever you come up with a model in your lab environment or a toy environment that you are like hustling in your laptop. But there are a lot of things that happen when you go into production grade environments, and you need to iterate on that model to get to the best model. So never ever is the case that your first version of the model is the version that is actually adding business value. Most of the times what happens is you make some assumptions in the lab environment or in the model development time when you're like coming up with the first model. Now, these assumptions could be an assumption that the customer will be reacting like this, could be an assumption that this particular location will be reacting like this. There are tons of assumptions. We call like usually the model development environment as an offline environment because there are no real users interacting. It's all like, so you make some assumptions, you make some heuristics, and based upon that, you create a model. But when you actually go into an online environment, which is like the production environment, a lot of those assumptions, a lot of those claims, they get validated, whether that is the right assumption that was made or not. So most of the times what happens is you get learnings from the production environment, go back into the development environment and do that in an iterative way. And this is exactly what happened at Lyft, because I didn't come from a traditional data science background, but it came more from a software engineering technical background. I wanted to have a more methodical approach for how we show these models business value, because ultimately, let's just take a fraud model. You can just like claim that the fraud is going to decrease by X amount of %, but is that really true? Unless you actually show that, it's just a claim at the end of the day. And that's exactly what happened with our project as well. A lot of times AI, the value of AI is not by how good this model is, but really how well the model has, how well the customers reacted to that model in production. And is that in alignment to what the business wants? And sometimes you may not even get the model that is in alignment with the business, because the customer's behavior is always changing.
Got it. And then what was that? Was it bottom line revenue for the surge pricing model, that sort of success you were able to show the executives?
Yeah. So it was mainly about revenue and profit margins per ride. Like every like even if you do a few cents, that's actually, when you look at a scale at the number of rides, that's a significant number. So that's why it's like you have to be very, very much like careful about this model, because if you weigh this way or the other, it could move the business in a very, very drastic ways. Could be positive, could be negative. So it's always that balance. Like you show too high of a price, you may actually lose out users converting the ride. You should too low of a price, you're actually losing things on the table. So what is that right optimal strategy is the key.
Got it. And then once you were able to show that success to the executives, and I love how you called out, a special skill set of articulating that to the business leaders versus just being a data scientist and being able to just work on your own. You really need to, have both of those skills. So once you're able to demonstrate that skill, did they give you more budget? Did you get a team? What happened?
Yeah, definitely. I think once you prove the initial use case, the value of it, definitely it just became much easier to go ahead and ask for more investment, more budgets, and really like hire more teams, or even like hire more data scientists specifically, and slowly like make it like almost like a engine, like a big team. But it's always one thing we have observed is that you have to achieve something that is reasonable first pass through of that model, that the model is actually moving the needle, because until you cannot show that, no one in the business side, and particularly business people, also don't know what are the right questions to ask about the AI. So I have seen that there's a lot of education need to be done from the technical side to the business side on how do they have to measure a performance of the model, how is it contributing to the business value, because that's something that it's lacking even today, that you need to bridge that gap as well.
Got it. And then, so you demonstrated success with this search pricing model. Did you then roll out the same model to all of the different regions, the different cities?
No. So I think over a period of time, I mean, Lyft has so many cities that it is operating. It becomes very evident that the customer behavior changes with each city, how the customer behaves. It's almost like you have a separate model in a city, because one city, certain features of the model might be more relevant. Another city, other type of features might be more relevant. It's exactly true in real life too, because you see that when you move from one location to another location, the priorities of the customers changes. Sometimes customers want a car fast. Sometimes they are okay to wait, but maybe like at a reasonable price. These are all like different sets of behavior that you will be observing, and managing that is not easy. Because every single squeeze that you would like to do is going to contribute a tons of revenue. And that's why it's very appealing to the business people, because they would like models more optimized, more localized in general, because that's going to give them the best business effort. But on the technical side, it adds a ton of management work on the model.
I was going to ask you, is it manual? Do you have to go city by city for each model? Is it?
Yeah, I mean, most of it is like that. And like you have to hire a number of people accordingly to make this process. It was not like, again, this was not something that we thought of on day one, that this would be the case. These are like learnings over a period of time that we have inculcated. And then we realized, like, because every single time, as I said, right, like most of the times people think that AI models, that you just do a one-time brush off, but that's not what is the reality. The reality is you will need to iterate on that model hundreds of times, if not even like thousands.
Got it. And let's talk a little bit about the stack and the environment you worked on there at Lyft. What kind of tools were you using?
So it's a heavy Python environment on the back end. So we were like, using Python quite a lot. And data science, as you guys know right now, it's Python oriented centric. Open source software was being used relating to scikit-learn, TensorFlow. These are some of the popular frameworks we have used. We also have looked into PyTorch, Facebook's PyTorch as well, and several other frameworks out there. But majority of it is driven by Python, Bash scripting for the backend.
Wonderful. And we'll go ahead and move on to Datatron. So most recently you founded Datatron. What drove that decision? How did it come to be?
So I think during my experience working in deep data science environments, I found that generally data scientists who are by profession, they're very good with the statistics and mathematical part of the equation. They do not have the necessary understanding of the production related operations you need to do. So you can't just put a code, but you need to think about how to convert a code into a proper container. How do you operationalize that at scale? How do you think about incrementally, when the traffic is incrementing, accordingly you need to scale. When the traffic is decreasing, you need to descale. There are a ton of operations tasks that are involved. So generally what happens is that, when data scientists, they're very good with developing the models. But unless this operations part is really solved, and when you're operating at a scale environment, it's very difficult to take these models. And that's why majority of the models that are prepared, they don't even go to production environment, because it's too difficult for those models to maintain and survive. As I said, most of the times these models just end up in a lab environment or a toy environment, and they never even get to see the end customer. So as I said before, that when you actually prepare your first model, you have to make some assumptions about how the user interacts with that model. Maybe the assumption is the user is not sensitive about price, or the assumption is the user in a particular location, for them, there is a peak hours, non-peak hours. There are some lot of assumptions that you make into the model. Now, all these assumptions, whether they are actually the right assumptions, or maybe they need to be corrected over a period of time, that only gets validated if you roll it out at a large scale. But this process I found was not easy for data scientists, because when you are developing a model, data scientists, they are the only group that they're interacting. But now you're like, when you get into production, you'll be interacting with engineering people, infrastructure people, DevOps people, pretty much like all the other part of the organization. But in general, there's a knowledge gap between like these groups. And unless someone steps in, sometimes someone could step in from the data science, or someone could step in from engineering, who can get to see what is the bigger picture that is happening. It's very difficult to understand both sides. And often this creates a ton of friction. I've been there. And sometimes it makes things much worse, unnecessary frustrations between cross-functional teams. Because ultimately, what I observed is AI, in theory, it can be a single team show, but AI in practice, in reality, it's a cross-functional team management. And you need to work as a collaboration between the teams, not like a siloed team, because that is where the difference, the way you're providing value to the business versus you're just doing AI for the sake of AI, there's a big difference between both of them.
Got it. And, obviously there's a lot of AI startups. It seems like there's a new flash in the pan almost every day. Where does Datatron fit in the ecosystem? Can you talk about the whole spectrum of AI solutions?
So yeah, there are a ton of AI startups, and every startup is like trying to get into the data science, how to make data scientists more productive, and how to make their life easier. So in a global span of things, the way we see Datatron, it's more fitting on the AI infrastructure side. So that's why the MLOps or the model governance, because we don't have anything on the model development side. Rather, we let the users or the data scientists, we give the freedom to them on whatever tools they want to use, whether it's Python, whether it's scikit-learn, PySpark, anything that they would like to use, let them use it, develop the models, and we take care of the infrastructure part. How do we take this model to a production grade environment, deploy these models at scale, maintain these models at scale, as well as monitor them and govern them, so that when things are not going according to their assumptions, we raise alerts. So we focus more on the infrastructure part of the equation, operationalization of the models. And operationalization, it's very similar to, for software, there is a term called DevOps, which is like the one that when you actually want to make the software alive in production, you need the DevOps. It's very similar to that. There is this MLOps concept where you want to make the AI into reality, you need the MLOps.
Yeah, can you explain? That's great. So Datatron has those two, basically two functions, MLOps and AI governance. For the audience today, can you just explain what each of those is, the MLOps and the AI governance part?
Yeah. So as I said, that the hardest thing that I have seen in my experience is there are a number of machine learning models getting developed, but less than a fraction of them are actually getting into a real production environment and showing a business value. So MLOps is that offering where you can actually develop models anywhere in any tools for different business use cases, but really take these models into a real production environment. And that's the offering mainly supports data scientists with cross-collaboration team efforts from engineering, DevOps, so that these cross-functional teams can leverage this platform on taking models to a real production grade environment at large scale. The AI governance is once you take models into production and these models are active, they're making decisions. In general, when a human is involved in a decision-making process, accountability is pretty straightforward. But if a model makes decisions on behalf of their customers at a very large scale, think of like, the population of the US, or the number of states in the US. It's a very large scale. Decisions are happening. Accountability by a model is not straightforward. It's a more involved, complicated process. We simplify that by bringing accountability. So, for example, which model in the forest of models is behaving anomalously, which model is making was built on wrong assumptions, meaning that the assumptions were made in the development environment, they are not the same that the model is observing in production environment. Or think of a model that is meant for a California region, instead it is actually getting a traffic from Wisconsin region. There are all these nuances that could go wrong once you take model into production. So governance is all about like, how do you have the peace of mind and controls on the model, so that you have to be prepared that if models go wrong, then you have a safe path, reliable path, and hence the word reliable AI of coming out of that.
Perfect. And I'd love to talk a little bit about a specific use case of when a company may realize they need a solution like Datatron. So, everyone on this call has experience with open source. I remember being a student, obviously not having a lot of money and relying on open source for a lot of projects, et cetera. And obviously enterprise prefer to build things in-house. So let's say they build their ML ops, they think they have everything up and running fine. What is sort of that first sort of crack in the foundation when they realize, what, maybe we need a solution like Datatron? What does that use case look like?
So generally, when you have an organization, the moment you show the value of AI, business value to the organization, immediately people would like to leverage more and more AI use cases. So it is always important that you can design a system very customized for a specific use case. Maybe think of like fraud as a use case or pricing as a use case. You can design something tailor-made for that particular use case. But as an organization, you will have very diverse use cases. Could be a fraud, could be marketing, could be sales, could be pricing, could be like engineering. It's a diverse set of forest use cases. So the moment you start thinking about scaling of use cases, or if the usage of the AI is going to be increasing over a period of time, then definitely you have to think of a system like Datatron, because maybe the system that you design is good enough for a specific use case, but does it work generic enough? And that's exactly where we come into picture, because we are all about like making and hosting generic AI use cases. So you can have any use case that your business unit is interested in, but we provide this centralized way of integrating with them and standardizing that use case onto our platform, so that you don't need to repeatedly do the same work that you've done for one use case. Now, to do it again from scratch for another use case is a ton of work. So it's like pretty much like eliminating all the headache that is involved, and also working with diverse clients within multiple industry, financial industry, retail industry. It gives learnings, because maybe you did not encounter a particular scenario, but another customer might have encountered. So that's where the advantage is.
Perfect. And since we have students as the audience here, what are top trends, products, or concerns in AI right now? And then we'll have you put on your Nostradamus hat here and predict a little bit. How about in the future? What are some of the trends that you see in AI, so they can build a skill set adaptable for what's coming next?
I think AI usage is going to increase in the next 10, 20 years. But there will be a ton of regulations on AI, how this AI need to be used with caution. The example for this is, when we had the whole housing financial crisis that happened in 2008, it was purely because lack of governance for the models making decisions and whatnot. And these models were not even AI models. Now, imagine the same thing when these AI models are making decisions at a very, very large scale. A part of it is adding business value to your organization, but also a part of it is are the models following the regular norms set by the government, set by the Congress? Because, for example, let's take an example, like if your model is like trying to schedule workers, but somehow inherently caused bias, not explicitly, but some other way, that's going to create a ton of lawsuits, for example, which is a bigger problem because you might be trying to add, like, let's say, tens of millions of dollars, but you expose it to hundreds of millions of dollars of risk that is associated. So one of the trends that we see is, as AI becomes more and more practical day-to-day usage into, just like software has been since the last 20 years, there will be a lot of risk that the organizations would be exposed to, and you need some sort of like checks and balances on how AI is being used for the benefit of the organization.
Perfect. Thanks, Harish. I want to make sure we have enough time to answer some questions. We got some great ones coming in. In fact, one was the next one I'm going to ask, so it's a great segue to jump in. Pankaj, we'll go ahead and ask you to unmute and allow you to ask your question to Harish. Go ahead, Pankaj. Go ahead, Pankaj.
Hello.
Yep, we can hear you. Go ahead.
Can you hear me? Okay. So yeah. So the question that I have is like, do you have any quantum computing experience with AI? So like, if so, like, what are the pros and cons of it? Because somebody just like, I had a conversation with somebody before, and then quantum computing was brought up, and then do you think quantum computing with AI will be the future?
That's very difficult to predict at the moment because quantum computing is still ton of it is still in the research mode at this point. It can go either way, but it's very difficult to predict. I know some companies, founders who are actually doing quantum computing, but most of the use cases, they're not yet practical enough. Major part of the research is still going. And there would be, like a lot more visibility need to be done before, anything can happen. But it's a trend at the end of the day. It's something that people are excited about. A lot of investments are going in. But would that work or would that not work? It's time will tell at this point. So it's too early to say at this point.
Perfect. And then Pankaj, if you want to go ahead and try again, I think you were having some audio troubles.
Can you guys hear me now?
Yes, now we hear you great. Go ahead.
Okay, perfect. Yeah, sorry. So my question was about like, how does one get into MLOps? For example, in the data mine, like we have been developing models, and we do see what you're saying that, it's really hard to get it into a production environment, get it running with the rest of the application system. So what technologies would you recommend us learning, and like, any other, how do you reckon we get started with it?
Yeah, so first of all, MLOps is its own field. Data science is its own field. So generally, sometimes data scientists tend to do both because of lack of resources. But sometimes they prefer to do more modeling rather than MLOps in general. So first of all, your area, what you would like to be in the next few years in your career, that is something that you need to get more clarity, which one will be more exciting for you. That being said, there are a ton of MLOps materials that are available, like white papers, case studies, or even like what are people doing, in terms of open source. There are some open source MLOps projects as well that you could leverage. The main point is that they're good enough for someone like you to get started and get things moving, but they may not be like commercial for like real commercial use. So to get into this, like I have given a lot of lectures, I've given webinars, even on O'Reilly as well. A ton of content is available online on how the landscape of different MLOps technologies are happening. There is no such thing as like this is a standard still at the moment, because it's a relatively new field, new category. People are like figuring it out every day. There's a new technology that's coming in the market. But that could be a good starting point, like Googling for MLOps technologies or MLOps white papers. Some research papers have been published. One of the research paper from Google, which got a lot of attention, was the hidden technical debt of machine learning. This was a paper that was published by Google, which really talked about, they talked about a number of concepts, but they talked about how MLOps is very critical for them in getting the business value from the models. So that could be one research paper I could refer to.
Yeah, and I would say follow Harish on Twitter, LinkedIn, and also follow Datatron on LinkedIn and Twitter as well. We try to share out a lot of those articles. Harish is always coming across this great content, and he's very generous in sharing that out. So that's what I'd recommend. For our next question, we'll go ahead and have Daniel ask a question. Go ahead, Daniel.
Yep. Hi, can you guys hear me?
Yeah, sounds great.
Okay, so my first question was, at the beginning of this meeting, you said you worked on Cassandra DB, which is a NoSQL database. Do you believe that regular SQL databases are being overtaken by NoSQL databases, or are they more like different tools for different situations?
So I don't think regular databases are going anywhere out. There is always different use cases that are applicable here at the moment. And I believe that when the whole internet really got started, probably relational databases were enough during that period of time. But as people were unlocking more and more web applications, Web 2.0, and all these scenarios, non-SQL databases, Cassandra being one of them, they found new use cases. So there is nothing like a dominance or this thing. I don't see it like that. It's more about what would be the right database for the use case that you're working on.
Okay, thanks.
Go ahead, Daniel. Did you want to ask? I saw you had a couple of questions. Go ahead.
Yeah.
And also before you do, I'd love to see some questions in chat from some of our other participants, Aiden, Elise, Mun, Mira, Nishay. If you guys want to ask a question, that'd be wonderful. Go ahead, Daniel.
Sure. So my next question is, are there any low-level computing concepts that you think are important for understanding how to optimize AI training and deployment?
It really depends upon the use case. There is nothing like a generic thing that I can recommend at this point in time. It really depends upon, obviously academia use cases are very, very different from industry use cases. So it's something, it will be on a case-by-case basis.
Sure, thank you.
And Daniel, did you have another question as well, or was that it?
I did have another question, but I think it was partially answered. So do you ever feel like in a fast-paced work environment, ideas with good long-term potential are being discarded for more short-term solutions? Or do you feel like whenever you deploy a final product, you've done everything you can?
It's very difficult to answer that, because a lot of decisions that we have taken, some things worked in the long term, something did not work. It's just like a lesson that is learned, and how do you course correct it quickly over a period of time. I think, if at all, like we can predict everything, then probably we'll be doing that on day one, and we would not encounter any issues on the software. So it's difficult to answer what you're asking.
Okay, makes sense. Thanks.
Thanks, Daniel. And Harish, I wanted to give you a little bit of time to talk a little bit about Datatron. I know I've sort of monopolized the conversation with my questions, which has been just wonderful learning about your background. But is there something else you want to share about, Datatron, what it's like to be running an AI startup, your experience engaging with the market, enterprise clients, obviously sort of a David and Goliath approach. Anything else you want to share?
Yeah, first of all, working in a startup itself is quite challenging. But startups is not always for everyone. It is generally like if you are like only in the right time in your career, right stage, that you would be willing to put in a lot of work, willing to learn things from scratch as needed. Probably that would be a right fit rather than other pressures and whatnot. It's always stressful in general, but how do you balance it out? Because you get to do things here in terms of like taking more ownership, more growth opportunities, really working with customers hand in hand. So here like our engineers code go live very quickly. We don't have like long cycles and whatnot. We move pretty fast. So whatever people develop, engineers, it lands up onto the customers pretty quickly, and you'll be getting fast feedback. That is something that is challenging and may not be appropriate for everyone at their stage in their career. Some people might prefer a less rigorous approach or a less stressful environment. So it's all something that you guys need to choose what would be your preference.
Perfect. And I see we have another question from Elise. So we'll ask you to unmute and go ahead and ask your question.
Thank you. So you mentioned that you are not primarily a data scientist and that you had to learn it on the fly. And I was really curious about your techniques for learning about a new field quickly.
Nothing, just jump in. I guess like I mean, there is nothing like a magic thing. I mean, like lack of data science, understanding made me more curious in general. So I was just doing more and more research myself on my own, which is not like, like obviously data scientists by profession, they have like PhDs and whatnot. I came from the other end actually, because coming from engineering and being data scientist, I have a different thinking coming from statistical and mathematical background. That will be a different set of thinking. But for me, it was more like initiative and more like, I don't have anyone to rely on because we had a very small company. So it was more like self-learning and more like putting concepts to practicality fast and, like validating whether that's the right path or not. So it was all a combination of things, but majority of it is initialization, taking initiative myself.
Perfect. And, all of these attendees, all of these students are going to be coming out of the data mine with a very marketable skill set. What would you say to them as far as making the choice between working at a startup, which I absolutely love. I love having, that Midas sort of the Atlas, the world on our shoulders, where yes, there's a lot of responsibility, but also you get to try a bunch of different things versus working in an enterprise where you have much more extensive resources. Harish, what would you say to them as they're coming out and making a choice between working for a startup or a larger company?
Yeah, it largely depends upon their choice. Some people want to see how a big company works and then come into a small company. Some people want to start with a small company. It all depends upon their preference, what stage of life are they in, because obviously there will be some financial part of the equation that they'll be considering, whether to consider for a startup or a large company. But definitely startup, it is something that will give you opportunity to do things, maybe less constrained in bigger companies because the process is already set up and you're just like trying to follow the process rather than trying to create a new path. So that's why growth opportunity wise, startups might be more, learning wise definitely more, but there are also benefits for big companies, and it's like your choice at what stage of the career you are in would be a right fit.
Perfect. Thank you, Harish. And Viba, you have a question. If you want to unmute yourself, we'd love for you to ask your question. And there you go. Go ahead. We can hear you.
My question is, you've mentioned that there is a knowledge gap between data scientists and other teams in the infrastructure. Like, is there a specific education that you'd recommend data scientists to learn during their undergrad before coming to industry to bridge that gap?
I mean, it's MLOps is something very new field. I don't think there are any courses in general that universities are publicizing for people to get into. And again, things are very different in industry when compared to academia. So, like taking models yourself, developing to production by leveraging whatever is out there in the open source, or even like in terms of some tools that are available in the market. It gives you some sort of experience in general, but there is nothing like a hard and fast way to do this to bridge the gap. But also you need to understand that no matter what you do, ultimately the team you're working with, whether you're part of the DevOps team or whether you're part of the data science team, you need to work with a lot of legacy technologies and legacy systems that have been in place since long time, even before you joined your job or anything like that. So it's all like comes by experience and really practically doing things. Definitely it'll help if you do the whole model lifecycle from development to production to application yourself. So that gives some sort of idea how things are working. But ultimately, DevOps is a legacy field. It has been there since long time. But machine learning engineering, which is that gap that you are talking about, is a relatively new field. You can take courses relating to machine learning engineering, if at all there are any.
Yeah, and just to add on that, everyone here, you're so lucky to be alive and in school at this day and age, because you have access to so many tools, and not like before where you really had to wait to get into a large corporation to get access to these tools. It's a DIY society, right? So you can spin up a server, you can take a TensorFlow tutorial on YouTube, you could actually download a data set for training as well as test. You can build models, and you can basically emulate everything that you would do in a professional setting. So you're very lucky. You're having some great education, foundational in data science, and then to move into that MLOps space, as Harish said, it is relatively new. It's just a matter of experimenting and playing around and basically teaching yourself, which I think you guys are, your generation is very good at that, obviously. So we'll go ahead and wind things down now. I wanted to thank everyone today. Thank you, Harish, for your attendance. This has been absolutely wonderful. Hopefully the students got some value out of it. Thank you to all the students who asked questions and everyone who attended. In particular, I'd like to thank the Data Mine for this opportunity. Heather, Maggie, Margaret, and Nicole, thank you for inviting us here. And to the students, if you did enjoy this and you would like to see, a follow-on or another webinar, we'd love to bring in someone from industry to provide a little bit more of that real-world experience, so you can ask questions to them directly. And from my side, that's pretty much all I have. So I'm not sure if anyone from the Data Mine wants to wrap things up, but thank you for attending. Thank you, Harish, and thank you on behalf of Datatron to everyone, and thank you to the Data Mine.
Thank you, guys. We appreciate it. And we obviously recorded this session, so we'll put up a recording on the event link, and you can rewatch it or share with any of your friends or colleagues. And thank you guys from Datatron for joining us today. And thank you, students.
Thank you, everyone. Take care.